We are ready to start our linked list. And to start your linked list, you have to create a structure that will represent what the node in memory will look like. And so I'm going to use the keyword struct, and I'm going to call my node node. And within the struct is where you declare what will be stored in this node. So in this example, we're just going to store one integer, but you can store anything. You could store integers and strings, and just like we would create a normal struct, you can store more than one data type in the struct. But for our example, I'm just going to create a variable called num, and it will hold one integer. And then no matter what you declare within this struct to hold for the node, you always will have a pointer at the end that will point to the next node on the list. And so I'm going to create my pointer of type node, and I'm just going to call it next. Okay, and so this is what our nodes will look like. But remember, you can have anything in this position. You can have one or more variables, but the last variable will always be a pointer to the next node on the list. So then the first thing we have to do is create a pointer called head. And what head is, it is going to point to the first node on the list. So I'm going to go ahead and assign that null pointer, because when we first run this program, when we create head, there will be no elements on the list, right? And so we don't want head pointing to anything. What I have going on in memory right now is a pointer variable called head, which is not pointing to anything. So it just is null. Okay, so that means that there are no elements in my list. And so I'm going to show you how to create an element and add it to the list. And I'll do this one time, and then in the next video I'm going to show you how to create a function to do that. But the idea is that we're going to create another pointer of type node, and we'll call this new node. Okay, so this will be the pointer variable that's going to hold the address to the node that we allocate in memory. And how we're going to do that is we'll assign it, and then we'll allocate the space for a new node dynamically. So what this looks like in memory is I have a pointer variable called new node. And then I go out into memory and I find enough space to create a node, which in this case is just one integer called num, and then one pointer variable called next. And wherever this is in memory, we're going to assign that address to the pointer variable new node. So new node will be holding the address to where this node is in memory. Okay, so that's what we got going on so far. Well, now that we've created the new node, we're going to have to put something into that new node's num variable, and then we're going to have to update our head pointer to point to that first element in the list. So I'm going to show you a different way for accessing the members of that node struct. So in the new node, I'm going to use this pointer operator. So I'm not going to dereference new node. This is the same thing as dereferencing with the little asterisk, but it just kind of reads a little bit easier when we're working with linked lists. So I'm going to say new nodes num member will be assigned, and I'll just assign it the number 3. So in memory, that memory location now has the value 3. And then I'm going to update new node next variable to be null pointer to indicate that this node is not going to be pointing to anything at the beginning. So this is just going to be pointing to null. Well, it's not actually going to be pointing, it just will contain null. Okay, now we want to update our head pointer to point to that new node. So to do that, we're going to say head is assigned new node. And in memory, that makes the connection between head and the address of our new node. So now head is pointing to the first element in the list, which contains the number 3.